My name is Jouko Markkanen and I'm from Remedy Entertainment. We are a video game company producing games you might know from franchises like Death Rally, Max Payne and Alan Wake. My presentation is about a topic of high availability. So I'm going to tell something about how we manage the availability of our Perforce environment, how we ensure that it's usable at all the times we need it to be available, and also highlight a bit of the specific requirements of video game development, which might be a bit different from the normal software development. Briefly, I'm here to tell about how we ensure the availability of our Perforce server and services to our users. That's the responsibility of our IT department. And one of my other hobbies is photography. I don't shoot people much, at least with camera, so I took my first selfie for this purpose. You can see it here. Briefly about the agenda, what I'm going to talk about. I'll introduce you to Remedy, who we are, what we do, how we use Perforce, and then we'll go into the main course, which is the high availability and how we ensure that one. And especially the case of Perforce application availability. We have also lots of other services under our responsibility in the Remedy IT organization. And one very key concept in high availability is how you monitor the service availability. I'll talk about that one as well, and finally some conclusions. But before we go into how we use Perforce, well, everybody uses Perforce the same way. They put stuff in, they take stuff out. I'll show you a brief clip of what comes out of our Perforce server.
Seconds, Jack.
Okay.
Let go of me!
I'm not gonna hurt you, but I can't let you go! Doctor, you're the only one who can fix this. I don't know the science, but I know the guy who murdered Will is using you.
Paul said people would try to steal our research.
Paul. Hard way.
It's collapsing. Move it! Move!
So, as you probably found already out, we are a video game developer based in Finland. So we only have one office there, which makes it easier to administer. We don't need to take account into a global organization. You might know us from our previous franchises, Death Rally, Max Payne and Alan Wake. What we just saw is a brief trailer of our upcoming Quantum Break title coming up next year for Xbox One. And also we are working on another project called Agents of Storm, which is an iOS mobile game available on app stores in selected countries at the moment in beta stage. There's a few fact numbers to give you some scale of our operations. We are a relatively small company, maybe not small in video game industry, but we have approximately 120, I would say 130 employees at the moment. We're growing all the time. And we've been in the business for almost 20 years. The key things to give some context to this presentation is the number of employees we have and the fact that we do AAA console video games, which are a bit different than regular software development. Some overview of how the video game development differs from regular software development. I saw in the attendee list there's quite a lot of game developers, fellow game developers attending, but as everybody's not aware, I'll go through the most important facts. First of all, we handle large content files. No, we are not at terabyte scale of files or stuff like that, like we heard previously in Pixar's presentation, for example. But I threw out some figures from our depot for this presentation. We've been collecting data in our Perforce depot since 2004, when we moved from the threaded visual source safe we used for earlier products. And ever since, we've gathered some 5 million files in our Perforce. If you count all the previous revisions that there's over 10 million files. And the head revision size, if synced to the client, would be something like 5.5 terabytes. This, of course, excludes the lazy copies, so the server storage is only 2.5 terabytes. And some comparison on how the industry grows or technology grows, and we must grow with it. Our previous AAA console game, Alan Wake, which was launched in 2010, contained about 1 million files in the source repository, and almost a terabyte of stuff there. Now, for Quantum Break, which has been in development for some time and will be still for some time, so the figures will grow from there. We've already produced 3 million files, and the total size is 4.5 terabytes. And also took a number of how many files we have of over 100 megabyte size. In Alan Wake, it was 1,300. Now we're at 7,000 for Quantum Break. And if you count the average file size, it's a bit over 1 megabyte. So I'd consider our Perforce database size of 30 gigabytes being quite modest in comparison to what we have on the disk otherwise. So launch files is one thing. It takes quite a lot of time to do the initial sync for a new client, for example. The other thing typical to video game development is complex dependency chain between the game source code itself and the tools used to create that content and the content, which are all dependent in some way. I'll try to illustrate this in this picture. On the right-hand side, there's the what goes in the shippable game. For example, a console DVD or a Blu-ray disc. There's, of course, the actual game program in runtime binary format, and then there's the content, which includes things like texture, graphics, animations, 3D objects, level maps, game worlds, scripts, stuff like that. Now, all of the dark red boxes are stuff that are stored in our Perforce server. The final binary format assets that come out of the build system are not in the Perforce currently. But if you make a change, for example, in the game rendering engine, a new feature, for example, the same change must be reflected also to the tools, the editor we use to create the content to the game because it uses the same rendering engine. And then we need to make the change also to the export utilities used to make the runtime content out of the source format. And when a build triggers, well, of course, we first must create the tool binaries for the developers to use, the export utilities, which basically actually are the same binaries as the tools. We just use them in a command line format in the build system. And then we need to export using those utilities the game content to a runtime format, and then we need to build also the actual game engine itself. And only then we have the runnable game. So handling these dependency changes is quite complex. This is a whole big topic worth of another presentation, so this is just to give some context of what we're doing. And as we saw, there's a lot of stuff that is stored in our Perforce server. Basically, if our Perforce server is out of business, the whole company is out of business. Everything we do is stored there, and everything that comes out goes into the game disk comes out of the Perforce. So this is a business critical system, and its availability is the key issue to us. So how do we ensure the high availability? Before we go there, we must first define what we mean by high availability. I checked out the Wikipedia definition, as everybody does nowadays. Wikipedia says in their high availability article that high availability means a system design approach as well as an associated service implementation to provide a specified level of performance. Now the key word here is the specified level of performance. Every organization specifies it differently. In large enterprises, which I don't consider us being, only 130 employees, do this usually by having the developer organization buying service from IT or an external outsourcing company, and they do a service level agreement which states that there must be a 5.9 level of availability, for example. For us, high availability means that we do everything that's feasibly doable to prevent failures in the system during our business hours. Well, one more thing about game development is that the business hours are really flexible. So under regular operations, we try to maintain the systems runnable from 7 a.m. to at least 8 p.m., usually 10 p.m. So we don't do any maintenance during those hours. During weekends, we might schedule maintenance if needed. So we're not really a 24/7 operation, but then again, there are the deadlines and milestones which precede some, or some crunch time precedes them. So during those times, we are 24/7 operation. So how do we achieve the specified level of high availability? Wikipedia also lists 3 principles to achieve this. The first of those is elimination of single points of failure. So basically, to eliminate single points of failure, you must first identify what are the points of failure that might bring your system down. And then eliminate them, usually by adding redundancy. The second point is reliable crossover. So when a system component fails, not if, when, because they do fail, you need to be able to reliably switch over to the not failed redundant component. And this is usually done by software, and you must take care that that piece of software doesn't produce another single point of failure. And then finally, you must detect the failures. The user mustn't see the failures. They must be transparent to the user. but the operations must see the failures and react to them so that when the next failure occurs, the redundancy has been returned and the service won't go down. Now we get to the architecture, how we handle high availability in our IT services. Now this is general, it's not specific to our Perforce server, and this is the approach that we use the lower level methods to provide the high availability, because we can use the same methods for our email service, intranet, file services, whatever. And it all starts from a reliable storage infrastructure. We use shared storage area network, which in this picture I've drawn it as a single component because it shows to every other parts of the system as a single entity. But in reality, the storage system itself has full redundancy. There's multiple power supplies, multiple disk controllers, multiple storage area network controllers, and of course multiple disks in a RAID configuration. So if any of those components fails, the system reports it to our IT, and we get the vendor to fix it within 4 hours. Then, of course, there's the storage area network. Storage area network is done using, basically we use iSCSI storage area network. So we have 2 Ethernet switches which are both active all the time in normal operations. Both carry active storage paths. So if one of the switches fail, again, we are still operable using the other one, and there's a 4-hour hardware maintenance, 4-hour response time for the hardware maintenance from the vendor. Now, the next layer is, of course, the physical servers. What I actually forgot to add to the slide is that we virtualize our servers. So our Perforce servers run as virtual machines. And we have several physical hypervisors running those virtual machines. And the management solution there, in this case, we use VMware, where the management software detects if the virtual machine fails, or if the hardware beneath the virtual machine fails, and fails it over to another machine. It can be done using sort of hot standby methods as well. In our case, we've configured it simply to restart the server on another hardware, which of course will produce short downtime, like 2 minutes or something like that. But we found that to be tolerable for us. Then next up is the local area network. As said, we don't have remote offices, so we don't need to worry about the wide area network redundancy, but we do it on the local area network. This is pretty much similar to the storage network side. There's 2 switches, 2 routers, and they're both active under normal operations. Then this is sort of the borderline where the high availability or redundancy ends. There's still components before the end user. The first is the access switch in the network, which is not redundant. We've found it's not feasible for us to do full redundancy all the way to the desktop. Instead, we opt in for the fast manual recovery in this case. So if the access switch fails, we find it acceptable for that part of our office, which is 10 to 20 users, to be offline until the switch is replaced. And for that, we have a cold standby switch in our storage. We just plug it in and load the configurations from a backup, which we do have, and get it running. It takes up to half an hour. And the same applies, of course, to the end user workstation, which is often forgotten. in our case it's deliberately forgotten or neglected. If one user has a failure in their workstation, usually what fails is a power supply or a graphics card, because we are locked into consumer hardware. We need to do our development on the same hardware that the end product is being run on. And the consumer hardware does not stand the 8 to 10 hours per day full load operation for very long. So we have spare components. We have a hardware expert who can swap those components in 10 minutes or something like that. And in the worst case, we can replace the whole computer. It takes 1 hour to install the operating system and software images, and then the user can continue their work. Of course, in that case, if the whole computer has failed, they have lost the work since their last submit or shelf. But that's their problem. We tell our users that don't store anything only on the local computer. Okay, now something that high availability concept does not cover is the backups. It's not a replacement for the backups. There are still failures that can happen even though you have taken care of the availability of the actual service. There's like end user actions. Users accidentally delete files. Well, our users don't have the access to run obliterate on the Perforce server, so they, in the case of Perforce, they can't do permanent damage there. But stuff can get corrupted. We've actually even had a case where the Perforce server did corrupt its database due to a bug. So these do happen. In the case of Perforce, luckily very, very rarely. We need to take care that the backups are being done. Like a natural disaster could destroy all our data center, we need to be able to recover from that one as well. And to do that, we have a completely separate hardware running the backup system. Completely separate server hardware, completely separate storage hardware, and that stuff is being replicated to an off-site data center. And this same concept is being used for our Perforce replica, which I'll come to next. So how do we handle the case if, well, it's possible that the high availability environment we have still fails. Like it's possible that the Perforce server itself. We've also had the case where our Perforce server crashed every now and then. And well, that's actually what caused it to also to corrupt the database. We've added another layer of availability there by using a read-only replica. As I said before, the replica is run on a different hardware. So if we lose our virtual environment, if we lose the centralized storage, we can always fail over to our replica server. But this we have deliberately chosen not to do automatically, because if you consider the scenarios where we would need to use this failover replica, like database getting corrupted, we don't want to automatically fail over to a replica unless we know that it's not corrupted as well. So we do this manually if we need to. We've done it once, which was actually an operator failure case. Our Perforce server disks got full and on the master replica and it failed. And we had to restore, basically it corrupted the operating system and everything. So we needed to restore the whole server. In that case, we failed over to our replica server. And what I didn't mention earlier, we have actually several front-end servers for different projects. All of these replicate to a same physical server which runs multiple Perforce processes in different ports. So when we have this technology in place, there's another additional benefit we can use. We have the storage, shared storage system, which allows us to take snapshots of the storage. We do, on the master servers, we do snapshots every 4 hours. We do it by running a scheduled p4d-c command, which by the command does is that the Perforce commits any unsaved changes to disk, locks the database, and runs the command given as a parameter. And the command we give is the hardware vendor software that runs a snapshot on the storage hardware. So we get a consistent snapshot with intact databases as well. It takes 30 to 50 seconds to run the snapshot on our system and depot size, but we found that to be an acceptable. Actually, our users don't know about it, and I've never heard complaints about it so far. But the benefits we have for this is we have another mean of backup, which we can recover nearly instantly. A full backup of our replica server takes 24 hours or something like that. And to restore or recover it would take another 24 hours. This takes 30 to 50 seconds to restore, to mount the snapshot. It helps as long as our storage system is still alive, of course. If it fails, then the snapshots are lost as well, and then we go to backups for recovery. But another use case for these, which I've used often, is that we can mount a snapshot to either on the same Perforce server or to a completely different host and run p4d from that snapshot folder. And these are useful, for example, to test triggers. We don't need to do it on the live system, but we can do it on the live data, or to test performance stuff and such. And these could be used. We don't do it at the moment, but we've been planning to do it to run checkpoints and verifies on the snapshots and offload all that stuff from the actual Perforce host. Currently, we do it on the replica server. These tasks. So the last point, or the principle of high availability, was the detecting failures or monitoring. We have multiple methods for monitoring our Perforce service. This is from the Wikipedia article, the statement that a user must never see a failure, but the maintenance activity must, which I covered already earlier. The infrastructure, basically the layers of our high availability stack, each have their own internal monitoring mechanisms, which detect failures, like our storage system detects if a disk fails and emails our IT team about it. Network detects their own failures. Server has their own monitoring systems. But in addition to that, we use an open source solution called Nagios to monitor as well, also the hardware infrastructure, the same things that the hardware monitors itself, but also the application layer. In case of Perforce, we've done several custom checkpoints or check methods for monitoring the system availability. One is to check the process tables in the servers. We check that there's a p4d running. We check that we get the TCP connectivity to the Perforce port, that it's actually listening to network and the network path works. We check for p4 info output that it's expected. And then a custom check which was made before Perforce, as nowadays there's pretty good methods to detect replication failures out of the box, but earlier on it didn't have, so we created a check that checks change list counters on both replication partners, detects if they differ, and well, they might differ for a brief time, but if they differ for over 10 minutes, either the performance is an issue or the replication has stopped, and both must be looked after. And finally, P4 review daemon is a good monitoring tool if configured to send failures to the administrator, because if it does complex operations on the Perforce server, and if it fails, it immediately reports that, hey, your Perforce doesn't work. It's not made for monitoring, but it's a handy way to use that. So, if you're going to start implementing high availability for your service, Perforce service or any other, first, define what it means for your organization. What do you mean by high availability? And how much you're ready to invest into this. And build it one step at a time. Don't try to go full on. If you're running one single server with maybe some disk redundancy or something like that, there's lots of things to do. Do it one layer at a time. And then go back when you've gone through the whole stack, go back to that and the first layer and start investigating if there's something to improve. Like our storage system infrastructure is on its third or fourth iteration at the moment. And whenever you implement an high availability measure, make sure it's being monitored as well before it's put into production. And don't forget the backups. So that's it, what I had to say. Thank you.